Isaac Asimov, one of my favorite authors of all time, once said, "You can't differentiate between a robot and the very best of humans." Very true, Isaac. Very true. Hey there, everybody. Welcome to episode number 492 of this here electronic engineering podcast called Amelia's Weekly Fish Fry. Brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. Yes, my friends, we are talking about robots this week. Keith McMillen, founder and CEO of BeBop Sensors, joins me to discuss a whole bunch of cool topics, including BeBop's RoboSkin that can provide robots with a sense of touch. We also chat about BeBop's intelligent sensing technologies, which can transform any surface into a touch surface that naturally blends into its environment, and why Keith believes that intelligent interfaces will change the future of how we interact with machines. A little later on, I also take a closer look at a new robotic learning method called WHIRL, developed by a team of researchers at Carnegie Mellon University that could make teaching robots easier than ever before. Hi, Keith. Thank you so much for joining me.
Hi. Nice to meet you. Nice to be here.
Excellent. Okay, so for my audience who may not know, what is BeBop Sensors all about?
BeBop Sensors makes fabric sensors that measure pressure, motion, relationship data between humans and objects or humanoids and objects. They're flexible, they're lightweight, they're very sensitive and robust. We can survive inside a sneaker as well as inside a drum.
Cool. Okay. So when I was doing research for this interview, I ran across the BeBop RoboSkin. So Keith, please tell me more about that.
Well, we've been watching the gain in intelligence, artificial intelligence, automation, the Tesla cars, robotics seems inevitable. The population of Japan is aging very quickly. They're very motivated to be able to make care bots to take care of the elderly. Same is true in this country. And in the last couple of years, the progress made is quite tremendous. One thing lacking, though, has been an easy way to provide the robot with a sense of touch. There are cameras for eyes, microphones for ears, all very straightforward. But with RoboSkin, we have a flexible, soft covering, all said about 1 millimeter thick, that can go on any part of a robot's body and can measure very accurately, even more so than a human. The finger, for example, can detect points, the human finger, that can detect points that are 2 to 4 millimeters away, 3 to 4 millimeters for most people, and forces within a certain range. So our RoboSkin is more spatially accurate than human skin and can measure forces from 5 grams to 50 kilograms, which that's per point. We have 80 sensors on a fingertip. So that really does make that finger as good as a human, possibly better in some situations. We wanted to design with that as a goal so that people designing with our technology, our RoboSkin, would not have concerns about its ability to match human skills.
That makes sense. Now, I was also really interested in your Note Touch. So tell my audience a bit about this technology. And you guys also have a Note Touch software toolkit that goes along with it, right?
Well, the Note Touch is like an entry-level device. It's a piece of fabric with our sensors on it. It's like a 16 by 16 array at 4 millimeter pitch. And when someone wants to work with us, they'll want to know what is the basic technology. Fabric sensing is new. We're the only ones who do it. I started working on this about 15 years ago. And people need to have a sense of how it operates so that they can imagine a design. And the no touch is a great introduction. You can wrap it around objects. It comes with software to visualize the pressure or the movement. It's multi-touch. It can sense 10 fingers easily. And it also creates a data file that you can look at or play back. So it's a great exploratory tool.
So if my audience is interested in developing a product using BeBop sensors, you guys have what is called the BeBop 5-step process. So can you walk me through that and what's all included in each of the steps?
Well, it's marketing saying that it's different for everyone. It's usually an initial introduction, then getting used to the technology, quite often through a no touch. And then we help them define what they're trying to sense, and we'll provide parameters that allow them to make choices. We'll build some prototypes. They will play with them, confirm them, modify them. And then we can do production for them up to 10,000 pieces, which many companies like. And then we license the technology and sell them the fabric.
Okay. So Keith, let's talk about the future of human machine interfaces. How do you see these new kind of intelligent interfaces changing the way we interact with machines?
That's an excellent question. About 30 years ago, I put a lot of effort into voice recognition, speech to text for certain applications, and it was abysmal. You had to train the systems, but you had to train them not just once. You had to train them before coffee, after coffee, if you were tired, and they still gave you ridiculous phrases. But now I can talk to my iPhone and it gets everything right, almost without fail. I never thought I'd live to see that. And even though I'm in technology, I'm often surprised at how fast it changes. It kind of mutters along, and then all of a sudden it really picks up speed and it's exponential. And humans are not very good at perceiving exponential changes.
That's true. All right, Keith. Well, I think it's time for your off the cuff question.
Okay.
Now, a lot of us can't have our favorite foods these days for one reason or another, whether it's travel, lockdown, the restaurants closed, supply chain issues. So, Keith, if you could have one meal right now, doesn't matter where it's from, if you need a passport to get there, what would you have?
Chicken coq au vin.
All right, good choice. So why that?
Oh, I've traveled a fair bit. I've always enjoyed France, south of France. The food is so good. And even though I've tried to cook it myself, it's never the same. They have like 7 different types of chicken. So I don't know how they do it, but they certainly know how to do it. And yeah, there's no doubt in my mind. Chicken coq au vin.
I love it. It sounds delicious. Awesome. Well, Keith, this has been wonderful. Thank you so much for joining me.
Thank you. Look forward to hearing this and speaking with you again, I hope.
So, if you want even more information about BeBop sensors, I would highly recommend checking out my fellow EE Journal editor Max Maxfield's feature article called BeBop RoboSkin Provides Tactile Awareness for Robots. And you can check out this article by clicking the link below the player on this week's Fish Fryin' page on eejournal.com. So, what if robots could learn just by watching us? Well, a team of researchers from Carnegie Mellon University have just made a huge stride in making this a reality. Let me introduce you to a new robotic learning method called WHIRL, which stands for In the Wild Human Imitating Robot Learning. So what is this WHIRL business all about? Well, it's actually an algorithm for one-shot visual imitation. By using this algorithm, robots can learn from videos that show human interaction, and then from there generalize that information to create new tasks. If you're thinking Rosie the robot from the Jetsons here, Well, yes, I am too. So let's get into the details. First, this team started by adding a camera and their software to an off the shelf robot. And guess what? It learned to do over 20 different tasks, including opening cabinet doors and drawers, putting a lid on a pot, pushing in a chair, opening and closing appliances, and yes, even our most favorite chore, taking the trash out of the trash bin. So, what sets this type of robotic learning apart from other methods in use today? So, right now, teaching a robot normally depends on imitation learning, which is a human operating a robot to teach it how to complete a task. With this kind of learning, the process must be done over and over again before the robot will actually learn how to do the task. There's also a method of learning called reinforcement learning. In this case, the robot is normally trained using millions of examples in simulation and then asked to adapt according to real-world conditions. As you can imagine, both of these methods work great in structured environments with a single robot. But scaling and deploying, well, that's a different story. With WHIRL, however, since robots can learn from any video of any human doing any task and are not confined to a specific area, the scalability here is easily understandable. And get this team of researchers from CMU is also working on a version of WHIRL that uses videos from YouTube and Flickr. Shekhar Bal, PhD student at the Robotics Institutes in CMU's School of Computer Science, explains this aspect of their research. He says, imitation is a great way to learn. Having robots actually learn directly watching humans remains an unsolved problem in the field. But this work takes a significant step in enabling that ability. Now, as you can undoubtedly imagine, these robots trained by WHIRL didn't learn their tasks immediately. The first attempts to accomplish a task were a failure. But it is important to point out that none of the objects in these tasks, like the drawers, appliances, doors, and chairs, were modified or manipulated in any way to help the robots. But after the robot was successful a couple times at a specific task, it quickly understood how to accomplish the task and then mastered it. Sure, these robots aren't going to complete these tasks just like we do, but the end result was just the same. Wow. So if you want even more information about this super cool study, I've included a couple links below the player on this week's Fish Fryin' page on eejournal.com. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If you're into Twitter, you can monitor our tweets at EEJournalTFM. And don't forget, if you would like to follow my personal Twitter account, check out Amelia D. 1978. And hey, if LinkedIn is more your thing, sure, I dig it. You can follow us or me on LinkedIn as well. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series hosted by me. And you can subscribe to our EE Journal YouTube channel as well. Also, by clicking the links below the player on this week's Fish Fryin' page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. And if you'd like to further support this podcast, please leave me a review on Apple Podcasts. It really does help. Also, if you'd like any further information about the stories covered in today's show, just head on over to eejournal.com and look for this week's Fish Fryin' page. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's AMELIA, at eejournal.com, or post a comment on our forums on EE Journal. For the week of July 29th, 2022. I'm Amelia Dalton, and you've been fried.